Good morning all. My name is John Chandrasekhar, HOD Instrumentation. Today we are going to discuss about process flow diagram preparation. How we are going to prepare the process flow diagram. There are five important things we are going to discuss. The first one is what is process flow diagram, PFD. Second is what is process unit symbology. What are the process unit symbology used in this process flow diagram? Third one is the process stream information. Different streams are in the process. So what are the process stream, how they are going to denoted in the process flow diagram. The fourth in the stream data. How will you show the stream data in the process flow diagram? The final one is difference between the P&ID and PFD. You know what is P&ID? Piping and instrumentation diagram. This PFD is the process flow diagram. There is a between where what is the difference between both. So we can go to now presentation. The process flow diagram, there are four things, major things are there. The first one is the major pieces of equipment. There are two types of equipments are there. The mechanical equipment, two types of equipments are there. One is a static equipment, another is the rotating equipments. Static equipments are vessels, columns, heat exchangers, that are static equipments. Rotating equipments are pumps, agitators, compressors, that are these things. We are going to show the major pieces of equipments only in the PFD. Another is the streams, utility stream. First, utility stream we have to show air, instrument air, water, cooling water, steam, high pressure steam, low pressure steam, nitrogen. All utility streams we have to show in the PFD. Then process flow stream. Process flow stream is the feed, ethylene feed, crude feed, maybe it is another chemical line. So that process flow streams we have to show. The last one is the basic control loops, the important loops, feed forward control, feedback control, ratio control, that we are going to show in the PFD. Minor lines, minor streams, small lines we are not going to show in the PFD. A process flow diagram is a diagram commonly used in chemical and process engineering to indicate the general flow of plant, process and equipment. PFD is used to capture the main process equipments, main process stream, process design conditions in these equipments and the basic process control scheme in a single drawing. The entire process of a plant can be described using a few interconnected PFDs. As I already told, PFD is used to capture the main process equipment, static equipment and rotating equipment, and main stream and utility stream, some basic design conditions. For example, if you show a pump, what is the pump capacity, maximum pump capacity, maximum pressure, maximum flow, that is the design conditions we are going to show in the PFD. A process flow diagram generally includes following information: flow rate of each stream in case of continuous process, or quality of each reactant in case of batch process. There are two types of process. One is a continuous process, otherwise it is a batch process. In case of continuous process, the stream flow rate we have to show. In case of batch process, how much reactant we are using, quality or quantity of the reactant. Then composition of streams. Some streams having two composition, maybe water and crude, or maybe it's hydrogen, nitrogen, like that. Some streams composition will be there, air and fuel ratio. Then operating conditions of each stream, such as pressure, temperature, concentration, etc. So operating conditions, there will be two types of conditions will be there. One design conditions, another is operating conditions. Operating pressure, temperature, flow level, all basic parameters we have to show in the PFD. Heat added or removed in a particular equipment. If in case of you are using a distillation column in our heat exchanger, how much heat is added, how much heat is removed from the. In case of coolers, it is removed. In case of heaters, it is heat added. So that information we have to capture in the PFD. Flows of utilities such as steam, cooling water, brine, hot oil, chilled water, thermal fluid, etc. As I already informed, all utility stream, water, cooling water, nitrogen, oxygen, instrument air, whatever fuel gas. So all flows should be mentioned in the PFD. Then major equipment symbols, names and identification. I discussed these major equipments, static equipment and rotating equipments. Their name, symbols we have to use and their names also we have to put. Then identification. Identification is the tag number. Normally each vessel have their own tag number as per the customer philosophy, tagging philosophy. Any specific information which is useful in understanding the process, for example, symbolic representation of hazard, safety precaution, sequence of flow, etc. Any specific information if you want to put in the PFD, you can put it as a note or otherwise put a star or put a triangle. That information we can use it. All major pieces of equipment, descriptive name, unique equipment number, pumps and valves. There's pumps and valves also rotating equipments. That major valves we have to show. Minor valves, minor isolation valve, we no need to show in the PFD. All the utility streams apply to major equipment such as streamline, compressed air line, electricity should be noted in the PFD. A PFD should normally contain the following information about the plant process. Main process equipment with reference tag number, name, process operating and design conditions are also usually provided. Main process streams are normally provided with the reference stream numbers. There should be a stream number. Each stream have the number. One input to the column, distillation column or heat exchanger. One input stream should have the number, reference stream number. It should be noted that streams are different than the line numbers. We should have a clarity. If you go to P&ID process piping and instrumentation diagram, there will be a line number. But here line number will not be there. Line number is different from the stream number. Stream number is different from the line number. The stream that normally do not have any flow are indicated with the abbreviation, normally no flow. Some stream may be having flow during the startup. Maybe intermediately it will flow. Normal operation it will not flow. That case you have to put NF, normally no flow. That indication we have to. Basic process data for each stream is sometimes given in the PFD again each stream number. This includes data such as operating temperature, pressure, flow rate, composition, etc. For each process stream, sometimes this process data is represented for each stream number in a separate drawing known as heat and mass balance. Design conditions for a stream are not normally indicated in a PFD. It is nothing but each process conditions of a stream you have to put in the each stream. But if it is required, you have to add a tabular column. You have to add a tabular column, stream 1, stream 2, stream 3. Then what is the operating pressure, operating temperature, flow. Then stream 2, operating temperature, flow, level, like that. You can add a one separate tabular column. I can show the tabular column later slides. Important isolation valves are also indicated in the PFD. Not all manual valves appear in the PFD. Only a few which can improve the understanding of process from the PFD. You have to show the all important valves. All control valve, shutdown valves, even manual isolation valve also it is a very big valve, important valves. Now small isolation valves and drain valves you don't need to show. Some valves are indicated as normally closed or locked to closed depending on the requirement. You have to show the normally open, normally closed also that we have to show. Automatic valves, motor operated valves, emergency shutdown valves, control valves appear in the PFD without the associated tag numbers. You no need to put the tag numbers. Tag numbers will be in the P&ID only. Here you can show PCV, pressure control valve, FCV, flow control valve, like that only. The purpose is better description of process. Associated control elements are also represented very briefly on the PFD. Sometimes if you want to show the control loop, maybe one control valve, one transmitter, and one PLC or DCS. That loop we can show here. If it is required to understand, then you can show here. Notes are added wherever required to improve the understanding of the process from PFD. You can put a note wherever you want to explain more information, give more information. You can add note, small note. This stream is from this vessel. This is going to that column. Like that, small notes you can put it. Legend is a list of symbols used on the PFD with brief explanation. This legend can appear on each sheet of PFDs or can appear on a single sheet with other sheets referring to a legend sheet. Legend, what are the symbols we are going to use? That legend you have to mention in the each sheet. For example, one PFD, first PFD, we used some columns or exchanger or pumps. That legend you have to use in the same sheet. Otherwise, if the number of legends are more, you got to prepare a legend sheet. Okay, the legend sheet. Then you have to show the reference. Please refer the legend sheet number so and so like that. Interconnections from one PFD sheet to another are used for process streams and instrument control signals to maintain continuity between different drawings. In case of 2-3 PFDs are there, from one PFD to another PFD, if the stream is going, you have to show the interconnection from to. Similarly, for instrument signal also, maybe the flow meter will be in one PFD, control valve may be in another PFD. So you have to show the signal flow from this PFD to another PFD. This is one example, small example of process flow diagram. There are two destination columns are there. One is observer. Basically, it's one is observer, another is a regenerator. The sour case is the feed, that is called stream. Okay, makeup water, the top, that is a utility stream. I already told you have to show the main process stream also, utility stream also. It is called observer. That's why it is the observer name is there. Then the outlet is going to one exchanger, heat exchanger. Then it's go to another regenerator, and pumps are there, reflex drums are there. So utility and major streams we have shown in the major equipments also. For example, this observer and regenerator is the equipment, static equipment. Okay, this heat exchanger is the static equipment. Condensator is a static equipment. Reflex drum is a static equipment. But the pumps are rotating equipment. Then major valve in sweet gas line there is one valve. So here in rich amine line also one control valve is there. So level control valve is there. The important valves we have shown here. Okay. Some operating ranges. Already told we have to mention the operating the below 35 to 50 degree and 5 to 205 atmosphere pressure. So like that we have to important parameters we have to show in that one. These are different symbology, unit symbology. I told her that heat exchanger, water cooler, steam heater, cooling coil. If it is a water cooler, H2O inside, you have to write H2O inside. If it is a steam heater, yes, should be inside. If it is some other heat exchanger, then it would be a common heat exchanger example. Then the heater coil, centrifugal pump, turbine type compressor, pressure gauge. This is the stripper, and observer. Observer is from the top. You have to spray something. Stripper, from the bottom you have to strip it. This is the distillation column. A separator unit used commonly to crack liquid, contains miscellaneous component fractions. Then liquid mixer, a process unit that used to mix several components of liquid. Both are liquid mixer only. The difference between first one and second one is it having only one blade, liquid mixer. That another one have different levels, different blades may be there to mix the liquid. Then this is a reactor chamber. Different type of chambers are there. Then horizontal tank or cylinder. These are the symbols we are going to use in the PFD. This is a boiler. The boiler is a side. First symbol is a side view. Another is the symbol, boiler symbol. When you are going to show the fuel gas and air, boiler air, then the side view, that two circle, small circles, that you have to show. When you are going to show when a liquid is boiled, then that will you have to show. When you are going to show the utility, utility is the fuel gas is the utility, instrument air or other things are smoke is coming out, that you are going to show, then that first symbol. The another symbol is for process. Okay. Then this is centrifuge. Centrifuge is nothing but to rotating equipment. You have to centrifuge with the gravity. You have to centrifuge separate the two liquids. This is the gate wall. Symbols, different type of walls. Globe wall, gate wall, globe wall, ball wall, check wall, butterfly wall. So you have to see the difference between each wall. Check wall and butterfly wall looking similar, but there will be one small dot in the center. It's a pivot. Actually, it's a butterfly wall. This is a relief wall, needle wall, three-way wall, angle wall. Since PFD diagrams are small, not much stream information can be included. Since PFD is a preliminary basic diagram for the process, you cannot put all the stream information. The previously we have put the stream information. See the bottom you have to put the only here what you have put it temperature and pressure only. But if you want flow, if you want level, if you want density, viscosity, all information you cannot put in the bottom. One stream you can put. If it is 5 streams are there, then 5-6 parameters are there, you cannot put in the down. That's the way here we mentioned, since diagrams are small, not much stream information can be included. Include important data around reactors and towers, etc. Flags are used full stream data. Flags and full stream data. What is flags? What is full stream data? The next slide we are going to discuss. See, this is a flag. 600, one rectangular, the right hand side if you see 600 temperature, 24 pressure, 10.3 mass flow rate, 108 molar flow rate. Like that, these flags you can use it. Okay, wherever 24 is there, the right hand side if you see the stream number 2, right hand side, 24 and 600 both are there. So means that stream number 2 temperature is 600 and pressure is 24. So that flag you can use it. Instead of the process parameters, you can use some flags. Okay, like that. Here you can mention the name ethanol and H2SO4. Ethanol and H2SO4 you are adding to a reactor. Okay, so reactor is R100. The reactor symbology, the top you have to mention the reactor name and the number. It's not a tag number. It's a number. Tag number may be different. Okay, in the P&ID you can mention the tag number. Okay, that may be 30-R001 like that. Maybe it's a different symbology. So you can use this information, stream information with a flag. Okay, here 1 is first stream, ethanol and H2SO4. 2 is the bottom, 3, 4, 5, 6 like that up to 10. Last right hand side ethane 10. So 10 stream flags used. Okay, the previous this is flag with the process parameters. This is a process parameter flag. Here it is a stream flag. Okay, now see, this is the full stream data. As already I told, if it is small information you can put in the below in the PFD. If it is more information required, more streams are there, then you can add a separate table. See, 1 to 10 streams are there. Stream number 1, 2, 3, 4, 5. Then temperature, pressure, vapor fraction, mass flow, mole flow. All information captured here of the all 10 streams. Okay. Okay, now you understand what is stream number and all basic parameters, important parameters captured in a table. This table can be shown as a separate PFD sheet or below the PFD. PFD with the stream data. If you have a sufficient space is there, you can show the table below the PFD. If it is better, always better you keep the table below the, so that you can easily correlate the what is stream 1, what is the parameter. Otherwise every time you have to go to the separate sheet and refer. But if it is more streams, more than 10, 20, then you have to keep a separate sheet. Okay. Now PFD with control loop information. Already I discussed, told in some basic information, control loops we have to mention. Here one level control loop is there, two control loops are there. See, LIC here and LIC in the T100 distillation column, 100 one LIC is there, CV100 is there. There you are going to operate one pump also, T101, and one more CV101 is there. So these are the basic important loops you have to show in the PFD. So in the nutshell, PFD we have to show the static equipment, rotating equipment, flags you can use it, stream numbers you have to use it, stream parameters as a table you can use it, then important loops you can show. Okay. This PFD is real plant. So in the PFD you have to show two pumps as a P100A/B. The left hand side is a PFD, but a real plant in the right hand side. Okay, if you go to real plant, the pump will be different. See, 100A, 100B is it show different. But if it is in the PFD, so as I discussed, PFD in the plant showing in the PFD is different from the real plant. The PFD, the pumps, two pumps A, B, in case four pumps A, B, C, D, you have to show 100A/B/C/D. But in the real plant, even in the P&ID, you have to show all the pumps. That is the difference between the PFD Vs and real plant. The difference between PFD and P&ID. A piping and instrument drawing comprises more details than a PFD. It is developed based on information from process flow diagram, which is developed based on block flow diagram. There are two types of process diagrams. One is a block flow diagram and it's a process flow diagram, PFD. But PFD is the mother document for the P&ID. Okay. P&ID is a detailed form of PFD. Process engineers in coordination with piping, instrumentation, electrical and safety engineers are responsible for preparing the P&IDs. While preparing the P&ID, all discipline engineers, process, instrument, electrical and safety engineers sit together and discuss. Based upon the PFD, they can draw the P&ID.